Hi, and welcome back to class 2 of this series of tutorial about the impact dust volumetric. Now, in this class 2, we are going to see how to set up our simulation workflow around Pyro and organize our work. The idea here is not to have a proper simulation, not to have something really nice. It's just to really make sure that we have everything again, get rid of all the technical problems, and figure out what might be the potential issues that we will face during the simulation. We are going to organize the class in two parts. The first part is going to use the shelf tool here, the Pyro shelf tool, to quickly set up something and see how this works, to learn about the architecture of such a simulation, sorry. And then we are going to build our own network from scratch. So the fastest way to actually build a setup around Pyro is to use a shelf tool here, because we are going to do a dust. The closest thing to the dust is the billowy smoke here. And I'm going to use the shelf tool. So if I click on it, then you see it's asking for a source for the smoke. So I need to select the geometry for that. So I'm pressing escape to get rid of the tool. And I would like to use this one as an emitter because I want to emit the dust from the fragment. But I like to keep things separated, at least for the assets. So these are my assets, the one that I imported and cleaned. I'm going to duplicate it. So I press Alt and drag the node. Actually, no, let's just create the geometry from scratch. It's just better. Just call that wall emitter, okay? Dive inside and do an object merge. And for this object merge, go to the wall simulation and get out. Okay, so you should have the geometry here. Okay, get rid of this. Good. And I do merge wall sim here. Okay, so this is my object. Okay, I'm going to hide this and I'm going to emit from this one. So I go here, now I click, and this is what we have. Okay, so Houdini automatically created a few nodes for us. These are the two main nodes at the geometry level that it created, okay? And there are a few other nodes in there that have been created, inside my wall emitter geometry. Now, if you go to the documentation here about the Pyro network, you see a little bit of explanation about the nodes it just created for us. Now, this is the nodes that have been created at the object level, okay? Well, mainly those two, and then inside there, which is this one, we have this part here, okay? So this part is really about building a volume for the emission because we are in the Pyro world. Pyro needs some volume to be able to emit some density inside the Pyro object, okay? So it doesn't understand geometry, it understands volume only. That's why we are converting this into a volume. And this is the process now to convert this geometry, these polygons, into a volume. More on this later. Here we have the actual dot network with the simulation. Okay, so we have an object, a smoke object, that is simulated thanks to a Pyro solver. Okay, and inside this object we need some smoke, so we emit, we source some volume, we source it inside the object so that it's then advected thanks to the Pyro solver. And then we have some forces, obviously, to advect things the way we want. And last thing is this geometry here. This geometry is just importing the data from the simulation network, from this Autodop network. Why is it doing it? It's basically separating the simulation from the rendering. Okay, this one you cannot render it. It's better to render here from the data that you imported. So you have the fields here. This node here is going to be importing all the fields for the render. And this one is just for visualization. So you might be able to set up maybe visualize the velocity or visualize some masks that you built in there and that you don't want to render, but you actually want to visualize to be able to troubleshoot your scene. Okay, So that's the basic setup. Again, if you want to have more information on it, you can read the documentation. It's pretty well done. Now, we are going to build our own setup because obviously when you click on the shelf tool, it's creating a lot of things for you, doing a lot of connections, and it's a little bit better to build it from scratch so that you understand what's happening under the hood. Now, building our own simulation network, I'm going to focus mainly on this part here and this one. This one, which is the emission, I'm going to leave it this way, just the way it is, because I'm going to focus entirely on the volume sourcing in class 3, the next class. So far, the only thing you need to remember and to understand is that we need to convert the geometry we have here, all the polygons, into a volume. Okay, that's the only thing we need so far, and we will see more about this later when in the class dedicated to volume sourcing. Now here, so the AutoDOP network is a DOP network, okay, that they named AutoDOP network because they created automatically. So we are going to create our own network, okay, DOP network that I'm going to call Dust Sim. All right. And I'm going to dive in there and see what we need to build our simulation. Well, the first thing is we need an object. So object, and this is a smoke object. So I'm typing smoke as well, and this is filtering for me. This smoke object, when it's created at the origin. Okay, it's just a tank, a basic container, which is 1 by 1 by 1. Okay. And it's at the origin. And the first thing I want to do is to place it correctly onto my geometry. So a little trick here maybe, and here if I go to the wall simulation, here on my null, I created some presets to be able to get this information here. And if I look at the centroid, this is the position of the center of my wall. Okay, and because I want my box to start around this wall, I'm going to use those values. So copy parameter, okay, and then I go inside here and I'm going to paste the values. Oh, sorry, that's the size, center, paste values. There we go. All right. So now we have this object, and if I display it, this is what we have. If I ghost the other object, there we go. It is right at the center of the wall. I'm going to hide this and maybe hide the emitter. The emitter is the volume that we see here. Okay, so hiding the emitter and displaying this. Okay, so if I get back there, then I'm going to increase this. I'm going to give it a size, a default size of 10. All right, and now this is our container. All right, so it's nicely centered on the wall. That's good. Now I need obviously to be able to solve and animate this smoke object. I need a solver. So I'm getting a smoke solver. Okay, and I plug it here because it requires an object, and then I'm plugging this one into the output for the display. Okay. Now, this is working, okay? It's simulating. We have something, the blue bar here means that the cache is, the simulation is cached into the memory. Now, we don't have anything, obviously, because we don't emit anything inside. So I'm going to do a volume source. Okay, this volume source, I'm going to plug it here in the sourcing, the last input. And this volume source here, I need to tell it where to get the actual volume to source the density from. So I go here, and you remember that we created, I mean, the shelf created it for us, and I left it this the way it was, and it's in the wall emitter here, and I'm going to select the out density, accepting this. Okay, now we're not done here. So we are saying, okay, go get your information from this node here. Okay, and we see here that we have CD, density, temperature, and the velocity. So these are the volumes that it's actually going to be sourcing inside the smoke object. But we need to tell it, okay, do it. And this is where the operations comes into play. So we could add this here and say manually, okay, source my density volume, okay, and where do you source it? Into the density field of the simulation. And what do you do as an operation? Whether you add, you copy, you subtract, well, usually you go for add, and how much do you do that? So if I do that, let me check. Yeah, so we are actually emitting density now, okay? If you're lazy, like I am, you could go here and you have some initialization presets here. So if you select source, because by default it's source smoke, it won't do anything. But what you could do is do something like whatever, select another one and then come back to source smoke. And now it's populating for you these three parameters, density, temperature, and velocity. Okay, so we see that it's sourcing the density into the density field. It's sourcing the temperature into the temperature field, and it's sourcing the velocity V, because it's named V on my object, on the source object, and it sources that, it puts that into the velocity field. All right, now if I press play, this is what we have now. Okay, so the density is rising. Why is that? It's because we add some temperature, and the smoke is programmed with some buoyancy, and the buoyancy uses the temperature to make the smoke rise. Okay, so this is a default model of the smoke solver, but we don't need that, so we can get rid of this. The buoyancy is really here to simulate the hot air. Okay, so when you have some air that is hotter than the air around it, it's rising. Okay, it gets lighter and it's rising. This is why it's there, but we don't need that because the dust is more about particles floating in the air, so it gets the same temperature at the air. So I'm getting rid of this because I'm a bit paranoid. I'm going to get rid also of the buoyancy. I don't want anything to lift up. All right, and now it's good. It's not lifting. It's not going up anymore, which is good. And you know what? I don't need the temperature here in my simulation. We are going to set up a simulation. We're going to start only with the density and the velocity. And if we need it, we bring the temperature back inside the simulation. But at the moment, I wanna get rid of it and work with the minimum needed. Okay. Well, this is the actual minimum needed for the simulation, and you can see that. I'm going to press play. We're going to see that the smoke is emitted around the fragments. It's actually following the fragments, okay? And the velocity is there working as well, dragging all the smokes with it. If you're not sure about this, what I do usually is I crank up the parameters and see what's happening, if it's actually doing something a bit more obviously. And there we go. Yeah, you see that the smoke is actually going faster now. And if you doubt, I can do that while I'm talking about the rest. Okay, so another thing we might be missing here from this setup is the, there you go. You see that it's actually changing. So another thing we are missing in this setup is that the container here is static, okay? We could make it bigger and encapsulate the entire simulation range we want here as compared to the camera, okay? But it would not be really optimized because at the beginning we don't have much information, and we would be calculating all this information around it, all this data for nothing. Here we are really simulating everywhere, okay, around this density. But really what's happening is right here, and here we don't have anything, but still we are calculating it. This is where, and you can see that from the default setup, this is where the resize container is helping us. Okay, so I go back here. I'm going to do a resize fluid dynamic, putting it here. And now we need to configure this. So the first thing we need to tell is which field you are going to track in order to know how to resize the smoke object. Okay, and we are going to use the density because we want to have our container to fit around the density. All right. Now we have this. Let's see if it's actually working by default, and then we'll see. Okay, so we have nothing here. We have nothing is because here in the smoke object, we need to actually go to the creation tab here and say that the creation frame specifies a simulation frame. So we need to say, okay, actually, on the first frame, you need to simulate. And let's see that. I'm missing something. Yeah, the solvent creation frame. There we go. Okay, so now we have the emission at the beginning. We have the resize fluid dynamic, which is working around my simulation. Okay, and then it stops. Okay, why does it stop? It's because here we have a tab which is called max bounds, and it's going to clamp to a maximum value. So if I get rid of it and press rewind and play this again, now you'll see that it's actually going to keep evolving, to keep growing around the simulation. You see, it's not stopping anymore. Good. Good, so we have this. And then, well, I don't want really this object to grow and keep growing indefinitely, okay? Because really what I want is something that plays nice in my camera, okay? So if I just leave this with no max bound, I take the risk that it goes indefinitely growing. So what I'm going to do is I'm going to use the clamp, but instead of using the initialization static or dynamic, I'm going to use it from the object. And remember the bounds that we created in the first class, okay, this one, and I'm going to use it. Now these bounds here, okay, that I'm displaying, if I go in there, now you see that the box is going to stop growing with the bounds that we created earlier. Okay, so that's a nice way to actually stop your container from growing indefinitely. And now you know that it's going really to be simulating only what you need. Okay. Cool. So I'm going to hide this one again and go back here. One last thing I want to do, and I like to do, sometimes in this case, we don't have the problem. It's actually tracking correctly the emitter. But just in case, you can also go here, track by object, and use this and track your emitter. So the wall, okay, not the, I'm not going to track the emitter per se. I would like to track the geometry because might be better to actually track the proper geometry. So either you have two choices. Either you use the out here from the geometry, the wall simulation, or you use the merge wall simulation that we have here. Okay. Actually, maybe what I need to do to make something a bit more clean is to create a null that I'm going to call geo. Okay. And now I go back here and I'm going to say, okay, go and use my geo. Okay, that way I stick to the wall emitter. I'm not using my asset, so it's a bit more logic for me. And this way, the gas resize fluid dynamic is really going to track my object just in case it needs some help. In this case, it wasn't a problem. I think by default, I had the problem. Let me go back to this. Okay, let's play with this one. There we go. You see, we have the fragments going out of the box of the container. Okay, and so we don't have any more emission from this. So sometimes this happens, and to avoid this, you need to actually track the emitter, track the object that you need inside the tracking object tab. Okay, that's it for now. So what I suggest is I'm going to do a little simulation with a flipbook, and we are going to look at the flipbook to see what else we can improve. So here is the flipbook. With this flipbook, we can already see a few problems. The first thing is that it's actually emitting before the frame of the impact. Okay, here we already have some emissions, so I want to fix this. The next thing, which is quite obvious, is that we have some gap into the emission here. If you look here about the emitter, you have one frame. In between the frames, you have some holes, and this is due to the fact that we are missing some information, geometry information, in between the frames. Okay, so we are taking snapshot for the emission, and in between we don't have anything. So we will see in the next class, I'm not going to take care of this now, we'll see during the volume sourcing class how to overcome this, and we'll find some work around this. And the last thing I was thinking is, okay, the shot is 150 frame, but really to be able to work, depending on if I need to work on the impact or if I work on the falling of the dust, I can reduce the timeline so that I don't have to wait all the time for 150 frames. This is something that I'm going to come back on, but basically you want to be as fast as possible. You want to have as much turnaround as possible in the least amount of time. So you will need to reduce your frame range so that you can work a bit faster. So, well, let's do that. I'm going to reduce that to 100, okay? Then we said I would change the start frame, so I changed that to 31. And now if I press play, then I see that I don't have anything for a while. It's actually waiting a bit. So it starts simulating at frame 31, that's good, but it's waiting to actually emit the density up until frame 63. So there's something with the resize. I'm going to deactivate the resize to see if it's due to this. Going up. Simulating, no, it's not. Okay. Oh, okay, I think I know. Go to the smart object. Okay, so on the creation, I made you check these two boxes, the solve-on creation frame and the creation frame specifies simulation frame. This one, as you can see in the explanation, is changing. It's not using the $SF. It's actually using the $F. So basically, it's using frame 31 as the start of the simulation, but then there's an offset. So I need to uncheck this one. And then I press play, and now we have the simulation starting at frame 31. So we are actually using this one specify the frame of the timeline and not the frame of the simulation since the simulation started. Okay, now I can use this guy again. Go back up, press play. Good. So we have our setup working now. It's emitting when we want it. We have the box, the container evolving, resizing correctly. We have the stepping, but that's fine. We are going to fix that in the next lesson. And that's cool. So we're good with this. Come on, stop it. We're good with this network here, so I can get rid of this one. All right. And now the last thing is to prepare this one. So this one is quite easy, but needs to be done as well. We are not rendering directly from the dot network. Okay, never. We are actually importing the data into a geometry object, which is this one. Okay, and we are rendering this one. So I'm going to, like I said, I want to do it from scratch. So I'm going to create my own geometry here. I'm going to call that dust. Okay, and what it's doing, it's basically importing the field. This one for the render, this one for the visualization. So I'm going to do the same. .io, this one is a digital asset that is built on some other assets. to actually import the field. And this one is a DOP import. It's when I double click, I cannot get into it. It's a proper node. So I'm going here and I'm going to do a DOP IO. Okay, this one is going to be for the rendering, and I'm going to use a DOP import, and this one is going to be for the visualization. For the two guys, I need to define which DOP network I need to use. So it's the Dust theme in my case. Copy that here as well. Okay. Now here I need to tell which object I need to import here. Okay. So if I go back to my Dust theme, this is the smoke object. This is the object I want to use. And the name is defined here. So if you change that, you need to use the name you put here. But if you middle click here, you see that $OS is using the name of my operator. So this is really the name that I can use for the imports. And I'm going to do that here. Okay, smart object 1. Why is it red? Why is it red? Because it's a DOP node and I need the full path to it. Dust theme smart object 1. Okay, now we have it. Cool, and now we need to tell which fields we need to import. So again, here you have some presets. So you could choose the smoke here, okay? And now we see that it's working. All right, so this one here, it's going to, let's say, import fields. Okay, and now I'm going to work with this one. Okay, then we have some issue here, invalid source 0. All right, so this one, we need to say import, not geometry, fetch geometry from top network. I think this is good. Now we have nothing. We need to tell which geometry we need to import. And that is, if you go in there, bring your geometry spreadsheet here, okay? And inside the smoke object 1, you should have some visualization here. Okay, and this is the data we are going to import. So really get this name, visualization, come back here, put visualization, okay. We still don't have anything, and that might be because if we go here to the visualization, so this one is reflecting this guide visualization tab here, okay. And it's really importing the multi-field, okay. So if I display the multi-field instead of just the density, I have nothing because I have to actually set it up. So if I click on the bounding box here to display the bounding box, and then here I use the density to tell, okay, actually display the density. You could use also the color here or the temperature if you want, if you had a fire, and you could use also the emission here to this one is used more for the fire, this one for the color maybe. In our case, we don't need that, so I get rid of it. And yeah, you can add some more information. You can tweak this. You can increase the scale of the density if you want. For now, I'm going to leave it this way. And so if I go back to my dust, then you can see here, it's actually working now. Okay, so I have this for the render and this for the visualization, and I'm going to reflect this. There we go. Okay, render, display. I'm saving my file, and that's good. All right, I think our setup is done now, so I can get rid of this. I have my dust simulation with my dust object, and I have my emitter. It's all working good. So that, I guess that concludes this class 2. We've seen how to set quickly a pyro setup. I usually do that. I usually go here on the shelf, use this tool because it's quick, okay? And it's also, I use it as a cheat sheet because I don't always remember what to do, what to connect. So I use that, it's quick. And then I repeat a part like I did with you here. Sometimes I use it to do everything from scratch. Sometimes I just copy paste the nodes that are set up for me. And then so after we've seen the architecture of this, we built our own. Okay, we've seen a couple of problems and things that you might want to be careful with. Remember, it was the start frame here. We had issues with the gas resize read dynamic with the max bounds. Also with the tracking object, I showed you, we didn't have any problems here, but it could cause some issues. So don't forget, in case you have some problem, to add a tracking object here. We had also some issues with the creation here. It was not checked on by default. Okay, it was checked off. And also, I made a mistake. I checked this one on at first. Okay, but it's really not this one you want to check on, because then it adds some offset in the timeline when you have a start frame which is different from one. Okay, so then I went back here and deactivated this. All right. Okay, well, we're done here. And I guess I see you in the next class for the volume sourcing. Bye-bye.